The next question. This is going to be from chapter 12. A company wants to determine if its employees have any preference among 5 different health plans which it offers to them. A sample of 200 employees provided the data below. Test the claim that the distribution of preferences is uniform. So they survey 200 employees and they ask him what plan do they prefer. 32 employees says plan 1, 18 says plan 2, 30 says plan 3, 55 says plan 4, and 65 say plan 5. The question is, we need to test if the preference is uniform. Uniform means is the same regardless of the plan. So it is the same for plan 1, 2, 3, 4, 5. This is called the goodness of fit test, and the null in the alternative hypothesis will always be stated as follow. For the null hypothesis, you have to state that the distribution of preferences as given in the problem or as claimed, and the alternative hypothesis will be the distribution of preference is not as claimed or as uniform. Here we need to test that the claim that the distribution of uniform means, as I said, they are all the same. So HO will be the distribution of preferences is uniform, and H1 will be the distribution of preferences is not uniform. And our claim is going to be in the null hypothesis. Here's what we're going to do. Those values that are given right here, 32, 18, 30, 55, 65, are called the observed values. So we have to put them in StatCrunch under one of the variables. And then we have to put in the expected values. Based on the claim, what values should we expect if the distribution was uniform? Well, we have 200 employees, guys. If the distribution was uniform and we have 5 plans, how many each plan should get? It should be 200 divided by 5, 40 each. So the expected values will be 40, 40, 40, 40, 40. We put them there. We run what we call the goodness of fit test, which is a chi-square distribution. And then we find the test statistic, which is called a chi-square, and then the p-value. And if the p-value is less than alpha or more than alpha, we make the decision accordingly. So let me show you how to go about solving this problem. You can see I already put the observed values in one of the variables. I put the expected values in the other one. And then now we're going to go to stat. And look, it says goodness of fit test. Okay. And it is a chi-square test. Okay, and where are the observed values? Let me just show you. Okay, observed values will be in observed values right here. And expected values, I put them in expected values column. And I think that's it. We can run the test. We're gonna hit compute, and then okay, after we hit compute, here's what we get. The degrees of freedom is 4. Here we have 5 categories. The degrees of freedom is always a number of categories minus 1. The chi-square, which is called the test statistic here, is 37.45. And the p-value is so small that StatCrunch says it's less than 0. You can make it 0 if you like, which is less than alpha, so you're going to reject the null hypothesis. So this is the test statistic chi-square, which is 37.45. P-value is less than 0.01, which is less than alpha. You can make it 0. We reject HO. And if we reject HO and the claim happen to be in HO, then we reject the claim. There is enough evidence at the 0.051 level of significance to reject the claim that the distribution of preferences is uniform. Okay. We're going to do another question on the goodness of fit test, which is number 17. And let me show you how this one works. A manufacturer of colored candy states that 13% of the candies in the bag should be brown, 14% yellow, 13% red, 24% blue, 20% orange, and 16% green. A student randomly selected a bag of colored candies. He counted the number of candies of each color and obtained the results shown in the table. Test whether the bag of colored candies follow the distribution stated above. This is a goodness of fit test. If you have more than 2% in a question, that means this is a goodness of fit. If it is 2, we do proportion stats, but if it is more than 2, we have to do a goodness of fit test. As I explained, the null hypothesis will be distribution of colors is as claimed above, and the alternative hypothesis will be the distribution of colors has changed or it's not the same as above. Okay, what does he ask for? Test whether the bag of color follow the distribution above, so the claim is in HO. These values, the frequency that are given to us are the observed values. And now, guys, we need to learn how to find the expected values. So let me show you how we're going to find the expected values. He gave me percentages. First of all, you need to figure out what the total here. I counted the total, and the total was 391. So in order, let's fix this one right here. Okay, let's find, the expected values. So expected values, I'm going to show you how to find that. For brown, he says 13% should be brown. So to find that, we should expect, if the claim was valid, we should expect 13% of the candies to be brown. So we have 0.13 times 391, which is the total, equal about 51. If you round to the nearest number, you're going to get 51. Let's go now to yellow. For yellow, it would be what? 14%. What is 14% of 391 times 391, which is, if you multiply 0.14 times 391, you get 55. And so on and so forth. For red, it will be what, guys? Red should be 13%, which is the same as above. We did it, should be about 51. For blue, it should be 24%, so 0.24 times 391, which is 94. For orange, we have 20%. So you have to do some manual work here. 0.20 times 391, which is 78 if you round it to the nearest whole number. And finally, 16% green, 0.16 times 391, which is 63. Those values, you have to put them in StatCrunch as the expected value. I've done that already, so I'm going to show you how they look like in StatCrunch. Here they are, observed values, expected values. And now we're going to run the test. Stat, goodness of fit test, chi-square test. Select the columns, it's observed. Select expected, select it's expected. Hit compute. And here you go. Chi-square is 14.621. And the p-value, guys, is so small, 0.0121. Let's write them down. So p-value is 0.0121, which is less than alpha, that is 5%. We're going to reject the null hypothesis. And since the claim happened to be in the null hypothesis, we reject the claim because we're rejecting HO. So you say there is enough evidence at the 0.05, not 1 here. 0.05 level of significance to reject the claim that the distribution of colors is as claimed above. The next question, which is the last one, it's from chapter 12. It's about the independence test. The independence test is, he will give you two variables and he will ask you, or two categories, and he'll ask you to test whether those categories are related or not related, independent or dependent. The contingency table below shows the results of a random sample of 200 registered voters that was conducted to see whether their opinion on a bill are related to their party affiliation. So the first variable is the opinion in a bill, which is approve, disapprove, no opinion, and their party affiliation, whether they are Republican, Democrat, or Independent. So your null hypothesis is going to be the opinion on a bill and the party affiliation are independent. The null alternative hypothesis will always be the variables are dependent. That means the opinion in a bill and party affiliation are dependent. And we're going to run what we call it a chi-square test or independence test, but I'm going to show you how to go about doing this. This is very tricky in StatCrunch, so please pay attention to how this is done in StatCrunch. Okay, here's how you construct the table. And you gotta be very, very careful. You're gonna put it in StatCrunch to look exactly like the table that you have. So look what I put in the headings. We have 3 columns that have data. One is for approve, one for disapprove, and one for no opinion. So you just type those here and you put the data under approve, you put the data under disapprove, and you put the data under no opinion. Right here before, you put the party, which is Republican, Democrat, Independent. And then you go to Stat, Tables. It is contingency table. So you go right there with summary and watch. Let's just reduce this. You want to select the columns that have data in them, and they are this one. Press and hold down the control key, the other one, and there is one more. 3. Now, row labels. You have 3 rows of data, guys, and they have labels. One is Republican, Democrat, and Independent, and I put them under party, so you just select the party right here. Okay, let's see what else. Okay, we need the expected values. These are the ones that you have in the table are called observed values, but we need to, if you want the expected values, just select the expected count. And this is the name of the test. It's chi-square test for independence. You need to select this one. Okay, and then you hit compute. There you go. Look what we got. We got the table again. And for each observed values, we have expected value. Like 42, the expected value for 32 is 38.76. For 20 is 22.8. For 14, 14.44, and so on and so forth. But what matters to us is what's the test statistic, chi-square, and the p-value. The test statistic is 8.030, and the p-value, guys, as you can see, it is a bit large, so probably we're going to fail to reject the null hypothesis if alpha, if it is bigger than alpha. So guys, chi-square is 8.03, p-value is 0.0905. We fail to reject HOY because the p-value is bigger than 5%. Look, this is alpha 5%. And conclusion, there is not enough evidence. Okay, what is the claim here? Let me just tell you where the claim is. The contingency table shows the results for random set to 100 users that was concluded. See whether their opinion on a bill are related. Related means dependent. So the claim was right here in the alternative. Okay, so there is not enough evidence at the 0.05 level. We failed to reject HO. That means we cannot support the claim. There is not enough evidence at 0.05 level of significance to support. Or we can say to conclude, if you like, to support the claim that the opinion in a bill and party affiliation are dependent. Okay, so again, in this type of question, independence test, HO will be always the variables are independent and H1 will be the variables are dependent. That concludes the study guide.